Good morning, everyone. In today's video lecture, we will try to understand command line arguments in C programming. And we also discuss one more important topic called as dynamic memory allocation. So based on the request of my students, I am creating this video lecture. So in today's video lecture, we try to understand these two topics in detail. So let us start with something called as command line arguments. So what is a command line argument? Arguments rather. So friends, we can pass arguments or parameters to main function also, right? So we can pass arguments to main function also. How is it possible? Basically, most of the time whenever we write C program, we generally don't use command line arguments, and most of the time people are not aware of something called as command line arguments. So this is how we write our main function. Generally, a main function will typically look like this, right? Sometimes people may use int main as the return type, right? It's up to you, either int main or void main. But does main take any arguments? Does main take any inputs? This is the question, right? Yes, main function will also take parameters, and those parameters are called as command line arguments. Why they are called as command line arguments? So first of all, we will try to understand why they are called as command line arguments. Then we will see what are those arguments and how to pass them to main function. So friends, we all know that execution of C program starts from main function. We all know that execution of C program starts from main function. So generally, main function will call the other user defined functions, right? But main executes automatically. Execution of your C program starts from main. Now, when execution starts from main, how do I pass parameters to main? So how do I give inputs to main? Because main is not an ordinary function. Generally what will happen is main will be the caller function, and from main we actually call other functions, something like this. You may be writing a function, you will write functions like this: add 5 comma 10, right? So you are calling a function called as add from main, and you can pass the inputs to add function. But whereas passing parameters to main means, how do I pass parameters to main? Because execution automatically starts from main, and how do I give inputs to main? That is the question. So what is command line argument? Name itself says we can execute C program from command prompt. In Windows, you know command prompt, and if you are a Linux user, you have something called as shell. So you can run a C program from either command prompt or a shell using a command. You can run a C program using a command. Most of the time people got habituated to run program directly from the editor. For example, if you are using turbo C editor, by using compile and run commands like alt F9 for compile, control F9 to run the program, we directly execute programs with the help of editors, IDEs. Whereas C program can also be executed from command prompt also. So today we will try to understand how C program can be executed from command prompt. And when you execute C program from command prompt, then you can give inputs to main also. Since inputs or arguments are given from command line, those arguments are called as command line arguments. So I hope you understood why the name command line argument, right? So friends, let us try to see what are those arguments, right? Now, for example, this is a main function. Now, I can give two arguments to main. Main will take two arguments. One is an integer. You can give any name for that argument, but in general, people use argc as the argument name. Here it can be anything, it's a variable, right? So it is an integer argument, and argc actually represents argument count. And this one, the second parameter, argc argv, right? Argument vector. Argv stands for argument vector. It is an array. You are seeing square brackets here, so it is an array, no doubt. And it is an array of strings. It's a array of strings. So you can pass any number of strings as input to main function. You may pass 3, 4, 5, any number of strings as input to main function, and that count will be maintained in argc. For example, I want to pass three strings. Hello, I am Ram, something like that. Then the number of arguments which I have passed, that number, that count will be maintained in argc. So argc stands for argument count, and argv stands for argument vector. Means it's a collection, array of strings. So this is how you give parameters to main. So friends, let me show you with a simple demonstration how to pass command line arguments in C language. So please observe here, I created an integer variable. Now I will run a small loop for I equal to 0, I less than argc. So what is this argc? Argc contains argument count, argc, argument count. Now if user has provided 4 inputs to main, this for loop will run 4 times, because argc contain the count of number of arguments passed to main. So I equal to 0, I less than argc, I plus plus. Friends, I am not doing much with these inputs. I am just printing the arguments which were passed to main, because my intention is just to show you how to pass inputs to main, how to pass command line arguments. So I am just printing it. So printf percentile s, new line, argv of I. So whatever arguments you have passed, those arguments will be printed with the help of this for loop. So friends, I hope this program is clear. If the program is clear, we can go to Turbo C and we can even test this program. So void main int argc, these are the command line arguments. It will take two arguments. One argument, first argument is an integer, int argc, argument count, means how many arguments were given, that count will be maintained. And second one is collection of those arguments or array of strings. How many strings you can pass? You can pass any number of strings. And a small for loop is written here to print those inputs which were passed to main. So friends, let us go to Turbo C and we will see how to run a program in which there are command line arguments, because till now most of the time people don't use command line arguments, and maybe they are not aware of running a program, how to run a program with command line arguments in Turbo C. Turbo C is the standard C compiler. I hope you are aware of it. So let me test this program in Turbo C, and I also try to help you in understanding how to run a program from command line. So let me switch to Turbo C. So please observe, I have typed the same program here, void main int argc, character array argv, int I, for I equal to 0, I less than argc, I plus plus. So friends, same logic, same code, whatever we have just now written in the notepad, same code is typed in this turbo C editor. So let me compile this program, alt C, compile, right? There are no errors and no warnings. Let me run this program, alt R, execute. Now what happened? I have executed this program, but what happened? Did I get any output? Let me check the console. See, I did not get anything, right? Now, where did I pass the arguments? Did I find any provision to pass the arguments? So what I need to do is in command line arguments, first run the program. Nothing happened, right? Now, after running the program, go to Alt F. In the file menu, you will find something called as DOS shell. Please, please press DOS shell. So this is the DOS shell. If you see, there is a path called as turbo C3 source. Let me type dir to see what is there in this one. What is the name of the program? The name of the program is args demo. I am typing dir followed by args demo. Did you see there are two files with the name args demo? One is the object code, another one is executable file. So friends, what I need the executable file. So let me run this exe file from the command prompt. This is called as command line argument, executing a C program with command line arguments. So I am running this executable file manually, argdemo.exe. See here, by typing a command, I am running the executable file of my C program. Since I am typing the command from command prompt, this is called as command line execution, and the arguments which I am giving, they are called as command line arguments. So please observe argsdemo.exe. Suppose the program which we have written just now, if you gave a different name, like you gave a name called as test, then it will be test.exe. Remember, this exe file will be created in a folder called as turbo C source folder. Generally, your source code is stored in bin folder, but exe files are created in source folder. Please locate that exe file properly and run that exe file. While running this C program from command line, I can pass the arguments. Please observe, argsdemo.exe is the name of the executable file, and I am passing the arguments now. I am passing the arguments like this. Hello, I am Ram Mohan Rao. Hello, I am Ram Mohan Rao. All these five strings are the five inputs to main, are five arguments to main, and I have written a small for loop to print the same. So let me run this program from command line. Did you see what happened? Hello, I am Ram Mohan Rao. So since I used a new line, everything came in a new line. Every string came in a new line. So friends, I hope you understood how to pass command line arguments to main and how to access them and how to test them from command line. So this is something about command line arguments. I hope it is clear, and then we will move on to something called as, so the moment you press enter here, or the moment you press exit here, now you are in command line, right? So when you press exit, when you type exit command, you will be returned to turbo C editor. So this is how you come back to turbo C editor. So just go through this small demonstration, and since it's a recorded video, you can play it again so that you understand the procedure, how to run a command line argument program, how to pass command line inputs to main, and how to test them. So I hope it is clear, and now we will move on to one more very important concept called as dynamic memory allocation. Dynamic memory allocation. So friends, in the very beginning of your computer programming using C, you might have created variables like this: int a, float x, etc. You might have even created arrays like this. So in all these cases, memory allocation, in all the above cases, memory allocation is done at compile time. Means when you compile the program, then itself the memory allocation is done, right? And once that memory allocation is done, it is fixed. It can't be increased or it can't be decreased. That's the reason it is also called as static memory allocation, right? So there are two important words. Memory allocation is done for regular variables and arrays. Memory allocation is done at compile time. Compile time memory allocation is also called as, it is also called as static memory allocation. What do you mean by static? Static means it is fixed. The size is fixed. You cannot increase or decrease. Imagine I created an array to store roll numbers of my students. And imagine I created an array of size 40. Now down the line, when I run the program, my user wanted to enter 60 rule numbers. Now what will happen? I cannot accommodate 60 because already memory allocation was done for 40 rule numbers only. So it leads to a problem called as a shortage of memory. The other case, I created an array of size 40, but when I run the program, my user has entered only 10 roll numbers, means he has only 10 inputs to give. So in that case, what is happening? It is wastage, right? And it is highly difficult for me to predict the size every time. Generally, in all real time applications, the input size will be decided by the user. Suppose I developed an application for a school. How many students will be there in a school? I can't decide it and I can't fix it. Same software which I developed for some X school can be given to some other Y school, and the number of students in X and Y schools need not be same. Then how do I fix this number? I can't fix this number. So this is the problem with static memory allocation. If I go for extremely very big number, it may lead to lot of wastage of memory. If I go for maybe a small number, then it may lead to shortage of memory. So static memory allocation, friends, has got a very, very, very important point, limitation or drawback, which is very important for you to understand. Static memory allocation suffers what problems? It suffers from shortage or wastage of memory. Wastage of memory. So, what is the remedy or what is the solution to this problem? Solution to this problem is we will not allot memory. Memory allocation should not be done at compile time. Memory allocation should be done at runtime. We will ask user how many students you have. If user says I have 150 students, then I will allot memory for 150 students only. Next time when I run the program, if user says I have 200 students, then I will allot memory for 200 students. So dynamically, since it can change, I use the word dynamic. And since memory is allocated at runtime, it is called as runtime memory allocation, right? So solution to the problem, to static memory allocation problem, is dynamic memory allocation, right? So friends, what is dynamic memory allocation? At runtime, we will ask the user to enter, we will ask user to enter the number of inputs, how many students you have. Suppose I am trying to create accounts for a bank. How many bank accounts you want to create? Like that, at runtime, I'll ask user the number, and based on that, memory allocation will be done. That's the reason dynamic memory allocation is more efficient, and it will solve the problem of shortage and wastage. There is no shortage and there is no wastage because we ask the user how many number of students you have, or how many number of bank accounts you want. What is your input size? We are asking user, and accordingly, accurately, exactly the required amount of memory is allotted. That's the reason dynamic memory allocation becomes a very, very important topic to understand. So how dynamic memory allocation is implemented in C language, let us try to understand. For that, there are few functions. Let us try to understand those functions. Right? malloc is one function, calloc is one function, realloc is one function, and the fourth one is free. So friends, there are four functions in which malloc, calloc, realloc is for memory allocation, and free is to release the memory. See, once my job is done, I don't want that memory anymore. So I use a command called as free to remove the memory which was allotted. That's the reason the fourth function is to deallocate the memory. First three are for memory allocation, and in first three, the most widely used one is malloc. So let us try to understand malloc. Malloc is a function which will take malloc. Let me write the syntax or function prototype for malloc. Malloc will take one number as input. So malloc will take one integer as input, and it returns a void pointer. This is very, very important for you to understand, because what malloc does is it will take one number as input. Let us say I gave 100 as input. For example, I gave malloc of 100, or maybe 160. Now I gave malloc of 160. So what malloc does is malloc will create 160 bytes of memory, or you can say malloc will allot 160 bytes of memory. Obviously, memory allocation is done in main memory. You are all aware of this fact. So 160 bytes of memory will be allotted, and starting address of memory memory is returned. Now there is an interesting point. How to return the address? malloc has to return the address, right? How to return the address? How do we store addresses? Addresses are stored in pointer. We all know that addresses are stored in pointer. So what malloc does is malloc returns, it will take that number as input from you. You said 160, it creates 160 bytes of space, and it returns that starting address in a void pointer. We all know that address should be stored in pointer. That's the reason address is stored in the pointer. But why malloc stores specifically address in a void pointer, and why it returns your void pointer is the question. So what malloc does? malloc creates malloc creates memory and returns starting address in a void pointer, right? Why it returns the address in a void pointer? This is a very, very, very important point to be noted, to be understood. And one of the most frequently asked interview question is why malloc returns the address by keeping it in a void pointer. Why not in an integer pointer? Why not in a character pointer? Why not in a double type pointer? Why not in a long int pointer? Why not in any other data type? Right? So there is a logic behind this one. what will happen is, please observe here, during malloc, when you have used malloc, what you have done, you have said how much memory you want. You said you need 160 bytes, but you did not tell what is the purpose of that 160 bytes. 160 bytes can be used if I am trying to store integers. Let us assume integer is 2 bytes. 160 bytes can be used to store 2 into 80 integers. I can store 80 integers, right? Because 2 bytes each. If I am trying to store characters, how many characters I can store? 160 characters I can store. If I am trying to store floating point values, floating point value, generally it will take 4 bytes. So 4 bytes each, then 160 divided by 4, 40 floating point values I can store. So I write 40 float values, right? Suppose if I am trying to store double type values, double will generally take 8 bytes. So 8 bytes means each 8 bytes. So 8 into 20, because 8 into 20 is 160. So 20 double type values I can store, right? Now please observe, friends, malloc don't know what is your purpose. You asked malloc to create 160 bytes, it created 160 bytes for you. Now, whether you want to store 80 integers, if you want to store 80 integers, that 160 bytes of space will be divided into 80 pieces of 2 bytes each. Logically it's divided into 80 units of 2 bytes each, so that you can store 80 integers. Or if you want to store 160 characters, then it can be treated as 1 by 160. Or if you want to store floating point values, then it will become 40 units of 4 bytes each. So what is your purpose? Whether you want 160 bytes to be used as 2 by 80, or 1 by 160, or 4 by 40, or 8 by 20, or some other type. What is your purpose? malloc don't know. So what malloc says, boss, I have created 160 bytes of space for you, and I have returned that address. I have returned that address in a void pointer. Because what is void pointer? It is neither integer, it is nor a float, it is nor char, it is not a double, it is not any data type. Void means nothing. So what malloc says is, I returned you the starting address in a void pointer. You convert it into integer pointer if you want to store integers. You convert it into float pointer if you want to store floating point data. You convert it into double pointer if you want to store double type data. So friends, what will happen? We have to explicitly convert that void pointer into whatever data type you are interested in. If you want to store integers, convert void pointer into integer, then I can access that 160 bytes as 2 by 80 units, right? So that's the reason, in important, very important, malloc intentionally returns you the address in a void pointer, because malloc don't know what is the purpose of this 160 bytes. I hope you understood. So what we need to do is, we need to convert that void pointer into appropriate data type of our choice, right? So let us try to see how malloc actually works with some programming example. So let me take you to turbo c. Yeah. So friends, void main. Now what I'll do is, I'll create n. What is n? It is just a normal integer where I want to store the size of the input, and I'll create a pointer, an integer pointer star p. To clear the previous output, I'll use clrscr. Now I'll ask the user printf, I want to create an integer array dynamically. So I'm asking user enter size of the array. Scanf percentile d ampersand n. So what n contains? N contains the size of the array. N contains the size of the array. Now if n is 10, I want to create space for 10 integers. If n is 20, I want to create space for 20 integers. If n is 40, I want to create space for 40 integers. So how do I create it? Please observe. Malloc. Can I write like this, n into 2? Please observe malloc n into 2, because integer is 2 bytes. N is the number of integers which I want to create. If n is 10, it becomes 10 into 2, 20. If n is 40, it becomes 40 into 2, 80. Seems to be correct, but please observe, this is not recommended. This is not a good way of using malloc, because friends, malloc of n by 2, I can't decide that integer will always be 2 bytes in C language. Depending upon your hardware, sometimes you may get 4 bytes also, especially if you are using a Linux machine. Generally, in Linux machine, most of the time we get 4 bytes for integer. So instead of me guessing the size of integer, what can be done is I can write like this: n into size of int. So did you observe what I have done? Size of int, size of is an operator. So wherever you run this program, in that machine, how many bytes can be created, how many bytes can be allotted for int, that will be calculated. So size of int will return me 2 in this machine. In your computer, maybe if it is 4, then size of int will return 4 accordingly into n. So n means what? Number of elements. So n represents the size of array. Size of int will tell me what is the size of integer in this computer. So this is the better way of creating or allotting memory using malloc. But you all know very well what malloc returns. Malloc returns you a void pointer. And since I know that I am creating an integer array dynamically, so I would like to convert this void pointer into integer pointer. How do I do it? Explicit typecasting, int star. So friends, this becomes my right hand side, and what I'll do in LHS, what I'll write in LHS is p. So what is p? You know very well. P is a pointer of what type? Integer type. Malloc created memory. Suppose if n value is 10, and imagine size of integer is 2 bytes, 10 into 2, 20 bytes of memory will be allotted, and that starting address is returned in the form of a void pointer. I converted it into integer pointer. So this is explicit typecasting, int star. This is explicit typecasting, int star. Suppose if you are trying to store floating point values, then use a floating point pointer, and in the typecasting write float star. So memory allocation is done now dynamically, right? Now how do I store some values in that array? Let me demonstrate with an example. So in order to iterate, I create or I take help of one more variable called as I, while, or for whatever loop you are comfortable, you can write for I equal to 0, I less than n, I plus plus. So what will happen, friends? I'll write one scanf statement to read the inputs. Ampersand, what is the pointer, right? So I'll write it p. because p itself is address, you all know that. Now what will happen? First input will go to p, then I'll write p plus plus because pointer has to be moved to next location. Let me compile this. Something missing? Yeah. Got it, friends? So this is how I can create memory dynamically and I can read inputs into it, right? So why I am saying p plus plus? Because memory got allotted for n inputs, and after storing first input in the first location, I need to go to the next location, right? Let us just test this program. Compile, right? Run. Enter size of array. Size is, let us say, 5. So for 5 element, for this 5 I need to give inputs 10, 20, 30, 40, 50, right? Just for confirmation sake, to make program more readable, I'll give couple of print statements. Enter percentile d values, comma n, means I'm making it more clear, right? Printf input collected successfully. So enter the size of the array, let us say 5 or maybe 10. Enter 10 values 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right? Alt F5. See, input collected successfully. If you want to hold on that output, use a getChar function. Right? See here, 6 inputs 44, 55, 66, 77, 88, 99. Input collected successfully. Right? Now, friends, please observe one thing. So we have seen how to create memory dynamically using malloc. Now what happened is, imagine this is my first input 55, 66, 77, 88, 99. Imagine these are my 5 inputs. Now what happened is, when I created the pointer, right, when I dynamically allotted memory using pointer, so p was initially pointing to 55. So p was pointing to 55. When I say p plus plus, it will be pointing to, when p was initially pointing to 55. So using scanf I was entering the inputs. So when I say p plus plus, it will go to next location and 66 will be stored. When I say p plus plus, 77. When I say p plus plus, fourth input was collected. When I say p plus plus, last input was collected. And in the last iteration, when I took the fifth input, one more time p plus plus got executed. So pointer actually went to the next location after 99. Suppose if I want to print those values, suppose I want to print those values which I have entered using dynamic memory allocation, how can I print? Because my pointer is not pointing to 55, my pointer is in some other place. So what can I do? I have two options. In the very beginning, take a copy of pointer p in some other pointer called as q, and use q to print these elements, or else you can bring this pointer p backside. You can move this backside, right, like this. You can move it backside. When I say p plus plus, my pointer moved forward. When I say p minus minus, I can bring my pointer backward. I can move it in the backward direction as well, right? So friends, this is how I can move the pointer, because pointer allows both increment and decrement operations. I can move my pointer backside to print those values, right? and I can perform lot of other operations like add all those array elements, whatever you want to do with arrays, and whatever you have done with arrays using your static memory allocation, all those applications can be done more effectively using malloc or using dynamic memory allocation. So I hope malloc is clear to everyone. Now before we wind up, quickly we will understand the remaining functions. So you have seen malloc was taking only one input, calloc will take two inputs, one is the number, comma, what is the size. Rest all is same. The return type of malloc and return type of calloc both are same. So if you observe in malloc, we were giving only one input. In fact, it was something like this. If you remember, I wrote n into size of whatever data type, maybe size of int. Suppose if it is calloc, what we will do, we have to write like this, n comma size of int. So that's the only difference. Malloc will take a single parameter, but finally it's a number. How many bytes of memory you want? Malloc will take a single number. Calloc will take it in the form of two parts, number of elements and size of each element. That is the only difference. Return type, everything is same as malloc. This is the only difference. Malloc takes one parameter, calloc will take two parameters. One is the number of elements, another one is size of each element, right? That's the reason there is no much difference, and basically malloc is more widely used than calloc. Now coming to realloc. Realloc is a function where you will pass an existing pointer as input and you will pass the new size as the input. What do you mean by realloc? Realloc means, for example, already I created a pointer, I allotted dynamically memory, and that pointer is named as p, and imagine I created or I allotted 200 bytes using malloc. Now if I feel 200 bytes is not enough, I can increase it and I can write p comma 300. So what realloc will do is same pointer which was pointing to a 200 bytes of space, it will increase that 200 to 300. Reallocation means what? Already something is there, you are trying to increase. Whenever you think it's not sufficient, you can increase it, then reallocation is used. But most of the time realloc is not useful because already you are allotting malloc only after taking input from the user. You ask the user how many inputs you are trying to give, based on that only you allotted memory, so the chances of reallocation are very very less. That's the reason realloc is not widely used. And the last function in dynamic memory allocation is free, which will take only one parameter, which is nothing but the pointer which you have already created. So suppose I have created memory like this, p is equal to, imagine p is a floating point pointer, so I typecast it using float, malloc of n into size of float, right? Suppose user has given n value as 200 and size of float is 4 bytes. 200 into 4, 800 bytes of memory was allotted, which is being pointed by p. Now once my program, see here a lot of statements are there, statement 1, statement 2, dot dot dot, right? Statement n. Now friends, imagine my job is done, right? My job is done, then why should I still hold that 800 bytes of memory? Then I can call this function called as free, which is used to deallocate the memory. You can say, boss, I don't need this 800 bytes anymore, you remove it, free of p, and then again you may have some other code, you can continue with that some other code. So in generally what will happen is whenever you terminate the program, memory allocation, whatever memory allocation was done, it will be deallocated, no doubt in that. You need not explicitly deallocate, but imagine you are running a very big program and some dynamic memory was created, and in the middle of the program you are dealing with something else, and this 800 bytes is not required anymore, but program is not yet completed. Imagine lot of code is there in this program. So why should I unnecessarily hold that 800 bytes till the termination of the program? Then in that case I can remove or deallocate that memory using free. So friends, this is how dynamic memory allocation works, and this is how malloc is being used. And we have seen malloc with a demonstration, we have seen malloc with a example. I hope it is clear, right? Based on the request of students, these two topics were explained again. And please don't hesitate to ask queries if you have further any doubts in these two topics, right? You can uh, post me questions either through the comment section of the video, or you can directly ping me in my personal window. I hope the concept of command line arguments and dynamic memory allocation is clear to everyone. Thank you.